should we say good noon? Is there such thing, Jim?
Yeah,
Because
sure,
we start
good
at
noon.
noon time. It's not before noon or afternoon.
Well, I mean, technically, right now it is like a little bit afternoon.
Happy lunchtime.
There we go.
So it's interesting weather in Texas today. And first of all, welcome to Sky Update of UTA Planetarium. My name is Levent Gurdemir, UTA Planetarium Director. And just you've seen Jim Bader, Program Coordinator of UTA Planetarium.
Hey.
Today we are here for another Sky Update, which we are going to talk about a little bit astrophysics, which is my profession. I'm an astrophysicist. But before, Jim, do you have anything important?
Important. We have shows tomorrow. We have 4 different time slots. You guys can come. If you have children, you can come check out our 1 p.m. show with One World, One Sky. It is going to be a fantastic show. Sesame Street production, so you know that it's going to be quality material. At 2 o'clock, we have Season of Light, which talks about how different cultures all over the world have celebrated holidays around this time of the year, and why, which is pretty surprising, I think. Classic show, though. At 6 p.m., I believe we're doing our new headline show, Unveiling the Invisible Universe, barring some errors or hiccups that may occur. And then 7 p.m., Pink Floyd.
It seems like we have great shows lined up at the Planetarium Theater.
Come check us out.
Come and see. And today I wanted to prepare some little bit astrophysics course for beginners, of course, using the real sky, because time to time they ask me what astronomers are looking at over and over in the sky. Of course, you know, we have some big telescopes and detectors, we can get some scientific data, but just by looking at the sky, we can actually learn a lot about the universe we live in. So this is always something we are curious, right? So let's start with Sky Update. Tonight, if it is clear, if the clouds go away, you will see bright things in the night sky, and especially this is one of the best time of the year. It's not only because this is holiday season, but also there are a lot of bright constellations, stars, planets, and plus there's a galaxy in the sky that you can even see by your just direct viewing. We call, I mean, I don't like the term naked eye.
Naked eye.
Also, there's another term for it. They call it unaided eye. It is also like a little bit pushing the word unaided eye. It means just like if you just look at it, you look at the right direction, right spot, you will see it. You don't need any optical device to see it. Am I correct, Jim?
Yeah, that's what it means. It means you're not using binoculars, you're not using telescope. Is
there a better word for unaided eye observation?
That honestly, unaided eye is
that means
that's probably the best one you could use.
Yeah.
And I think maybe you and I just do this because when we do shows with kids, if you use the word naked, even if it means, you know, totally acceptable reason, you know, like naked eye, you know, third graders just gonna laugh at you. What do you do?
Just as a general point of stargazing, let's not miss Venus, Saturn, and Jupiter in the sky. If you can align the background, Jim, to show all 3, it's gonna appear as like a 3 bright objects in line. That line is going to be the line which is called ecliptic, which is the plane of the solar system. So they always appear in line. They may be far apart from each other, but they are in line. So this is not surprising. I don't want to see the horoscope tellers coming and say all 3 planets lined up in the sky, and this is actually the implication for such thing or bad thing or good thing. I don't care.
Event, we're releasing the Titans from the underworld. That's what happens when you line the planets up. Haven't you seen that Disney movie before?
3 planets lined up in the sky. They are always lined up on the ecliptic line. It's not surprising. So the lowest one is the brightest one, Venus. The middle one is Saturn. If you have a telescope, binocular, That's a great object to look at because it has beautiful rings around it, and the largest planet of Jupiter is going to be the highest one. And if you notice, in the previous days, Moon was visiting these planets, and now Moon appears all the way on the other side of the sky. The Moon is still in the phase of what we call waxing gibbous. This is not completely full moon, but it is going to be full moon in a few days. So here's when you look at the moon, the first thing probably you would notice in the sky is going to be the moon. But now there are great constellations and stars, as you see, around the moon. Let's look at what is going on around. If you look right side of the moon, you will see an orange star. This is the brightest star of Taurus constellation. So if you find this orange star, then that means you found already Taurus. This V shape, the rest of the constellation may not be very obvious, but if you find the V shape, you'll find the constellation Taurus, and you can actually complete with your eye the rest of the pattern. If you bring back the stick figure, Jim, these two stars, they also belong to the constellation Taurus, and they are imagined as the bullhorns. So this shape is imagined as bullhorn. That's why I think that the name of the Taurus is coming from. As always, this is a great time to tell the purpose of the constellation. So there is moon in it, right? Mm-hmm. So if somebody asks me, where do I need to look at the sky to find the moon? Of course, the moon is going to be obvious. But if you ask like dim objects that are hard to find, this is the address system of the sky. I will say, to find the moon, look around constellation Taurus. So in Taurus constellation, there is also up above, you will see an object that is, it will look like a tiny constellation, but this is actually not a constellation. This is a star cluster, a very famous, popular star cluster called Pleiades. It has many names. Seven Sisters is also another name because 7 bright stars visible to, again, unaided eye. Just when you look at it, you can see 7 bright stars. Also, there are tons of different names in different cultures. For example, can name one, Jim?
Definitely. I name my favorite. Many people have seen lots of cars on the road, but only one car has stars in its logo, and that is Subaru. So in Japan, if you see this object, you probably wouldn't refer to it as Pleiades, but instead Subaru. I guess I can drop a picture of the Subaru logo momentarily.
So yes, Subaru is coming from this constellation, not constellation, star cluster. And there's another thing, like if you are using Sirius radio, there is a star called Sirius, the brightest star, which I will point out as in part of this sky update. So when we look at this, so again, I mean, different cultures name this differently. There's also Arabic name for it. It's called 7 candles. And when we look into this star cluster, we see a lot of stars. But different than constellation, these stars are grouped together. There is a gravitational relationship between the stars. This is the difference of constellations from star clusters. Star clusters means the stars are found in a cluster. In the constellation, they are just scattered in the galaxy, but from our view, they happen to be forming a pattern. But in the constellation stars, most stars are not gravitationally bound to each other. We also see stars are blue. So here, blue color in astrophysics or in the universe. It gives us the idea about the temperature of the gas. So blue gas is hot gas in the universe. That means the stars are hot. Here is
Sorry.
the
I just jumped in there with that, but you can see like, oh yeah, I kind of see where the logo is from.
but I see only 6 stars in this.
What?
Why?
What? Wasn't the oh, I'm behind it here. I gotta get rid of it. They can't see me. Wasn't one of them one of those candles going out, or one of those women shy?
I don't know. Anyways, let's go back to this star cluster. So it is, I also see some blue gas surrounding the stars. That means this is typical for forming stars. The stars are young, they are still pulling all the gas and dust onto them, and they are forming. They are growing up. They are not mature stars yet. So this is a great star cluster to look at. Again, 7 sisters, 7 candles, Subaru, Pleiades, whatever you want to name it.
It's got a ton going on.
All right, so let's move on. I would like to show you a very popular constellation, and we need to go down and probably go a little later, because right after sunset it is going to be so close or maybe below the horizon in the east direction. But if we go into a little bit later in the night, we will see a constellation, Orion. Orion is one of the brightest constellations in the sky, and it is very easy to find. So Orion is going to be a little below, and I would like to point 2 stars in Orion. So if you see this shape, this is very, it's a favorite pattern. It's very easy to find, especially at the center. There's like kite-like objects. To me, it's kite-like. It may be something different to you. This is the great thing about constellations. The patterns may not make sense with the official names or official understandings, and but when you look at it, you may find something different. So anyway, 3 stars in line, and this constellation will become important because of the 2 stars. Especially, it was the main focus of the science news last year. So there's a constellation, there's a star called in this constellation called Betelgeuse. Betelgeuse, when you look at the Orion constellation, it is going to be one of the brightest stars in it, because it's the second brightest star of the constellation, and it is going to appear slightly different than other stars, because it is going to be like a reddish orange color, as you can see here. So the orange color tells us another thing, another temperature from the gas at the star. So the orange scale is in the colder side. So if the stars are red and orange, we call them cold stars or cool stars. And if they are blue like this is the brightest star of the Orion constellation. It is Rigel. So Rigel is a blue star. As we said before, blue is for hot gas. If the gas is colder than blue, and it's going to appear in different colors. If you come to the orange scale, we are talking about 3,500 degrees, because this is the temperature of Betelgeuse. So you look at stars, you identify its color, then you know what temperature they are. Isn't that cool? Just by looking at, you can get this information. You do not need any space probe to go near the star, stick a thermometer in, and send you the result. It will take forever, actually, if you try to do that.
Just the distance alone, right?
So this is how we determine the temperature of stars.
Before we move to the next topic, Levent, we did get a warning from the chat to not say the name of that star another time. You've said it twice so far.
What happens if I do?
Maybe nothing, but this was a Brexton warning specifically. So.
All right. But how am I going to talk about this star without calling that star's name?
I got to be honest. I think you're just going to have to rip the Band-Aid off at some point.
All right. So that star, which star you know which star you are talking about, right? Okay, that star was in the news last year because we know it's a large star. It's a giant, supergiant star. It has it is 11 times of our sun's mass. So it's a very massive star. That star last year in March started dimming in the sky. So it is not as bright as like yesterday, and the next day it went even dimmer, and next week it went even dimmer. So that created some panic among the scientists because we know that before stars explode as a supernova, they dim. And then we started thinking like, oh, this star is going to explode as a supernova. Which if it did, that would be great because we would be one of the lucky people on Earth to observe supernova in the sky. But it turned out this star, without telling its name, it recovered its brightness in the constellation, and it turned out to be what we think happened is there was some gas cloud around the star that was directly in front of it at the time of March 2020, and probably that was blocking a lot of the starlight, and that was the cause of the dim. Otherwise, it would have exploded by now.
The excitement for that was really, really wild. I mean, this is something that I heard going to school. I heard when I was a little kid that, oh, this star could blow up at any moment. It could have already blown up. It might happen in our lifetimes. And then you also very commonly get the caveat that like, oh, it could also be like 100 million years from now, so chances are not good. But the thought that, oh, we're gonna get to see one of the brightest stars in the sky go supernova in our lifetime. Whoa, that was incredible. And then it didn't.
Do you know the first observed supernova, according to Chinese records, it was observed over China in 1054. So Chinese people reported something bright in the sky. So it was called a new star. That nova term is actually coming from nova means new, and they called it nova. So that star, the new star in the sky, got brighter and brighter in 10 days, and then got dimmer, dimmer, and disappeared from the sky. At that time, they had no idea what they were actually looking at, what happened there. So after the invention of telescopes and, of course, finding many objects in the sky, and with the understanding more and more of the star life, somebody remembered to the Chinese records. That was something seen in the sky. They know approximately where it was observed, and they looked at that location. They scanned that location with telescopes, and guess what they found?
You ready to light it up?
Yes.
I think I know which one it is. Can you give me a hint? They found a
Crab Nebula.
A fuzzy spot. Okay, let's bring it in.
Yeah. When they looked at, they scanned the area with the telescopes to see if there was any object the remaining from that mysterious the brightness, and it turned out they found Crab Nebula. Now it first looked like a crab. Probably it was used. A small telescope was used, and that's why it looked like probably in the low resolution environment crab. But it's not crab. It is a star wreck. So apparently Chinese observed a star going off as a supernova, exploding, and it turns into a big wreck with full of gas and dust surrounding the center remaining object. So center remaining object is also interesting. So what remains at the center from the star?
And this is what happens to a large star, right? Quite a bit bigger than our own sun.
Exactly. quite bigger, because even remnant is 1.5 solar mass.
The
1.5
little
times.
thing that's sitting at the center.
Exactly.
The
Exactly.
little thing.
The little thing. And you know how little is? It's actually 12 miles across. It's called Crab Pulsar. Yes, this wreck
I don't think we can see
remains
it if we zoom
a
into it.
pulsar at the center, and that pulsar spins pretty fast. It spins
No.
30 times a second. 30 times a second. When we roll a movie 30 times a second, which is the typical refresh rate for the computer monitors. When we roll a movie 30 times per second, it looks continuous to us. Our eyes cannot detect flicker from the movie. So it spins that fast. Of course, if you point a radio antenna, when the object spins that fast, and it's a pulsar full of neutrons, and when the neutrons are neutrons and electrons, so neutrons do not cause any radiation, but there are free electrons remaining from the initial regular matter. When there was like protons and neutrons and electrons exist, we call them atoms. When you form a neutron star, you actually combine the protons and electrons to form neutrons, and they get together with other neutrons, and some electrons got free, and if they are spinning fast, the free spinning electrons, because they are carrying negative electrical charge, they make a radiation. They produce a radiation. This is called synchron radiation. It is visible, not visible, but detectable in radio waves and also gamma rays. So first, there were the radio telescope antennas built. Those were giant radio antennas. They pointed them in space, and some of the objects they realized are causing or giving signals. Those signals were pulses, and when they look at the star, the Crab pulsar, what do you think that the period of the signals were?
30 times a second.
30 times a second. It was like beep, 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 beep in the radio. Actually, first they thought to be like maybe an alien communication system.
Oh no!
That somebody's sending us like beeps, telling them, hey, we are here, we are trying to tell you something. But it turns out actually it's pulsar at the center of Crab Nebula, spinning 30 times a second, and every time it turns, the electrical charge electrons are sending them electrical pulses. These electrical pulses, picked up by radio antennas, turned into a audible signal. Beep, 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 beep. It goes this way.
Wild. That's so strange to imagine a time when that was like turning your radio on to listen to Sputnik or something.
Mm-hmm.
I don't know. Anyway, it's weird that there was a time when we didn't know all the stuff we know today. If that makes any sense.
Yeah, well, all the stars in the sky or in the galaxies, if they are larger than or massive than the 3 times of our sun, they are going to explode as a supernova. So that's the fortune of these massive stars. Okay,
so is Betelgeuse going to oh no.
You I think called it 3 times, Jim, already.
Is that star going to go supernova, or do we know for sure, or do you?
It is going to go off as a supernova. Ooh. And that was the reason of the excitement last year, because you know what? It can go as a supernova anytime. It can happen tonight, or it can happen 500 years from now. We cannot really tell because this even 500 years is a very short time for the lifespan of stars. So we cannot really tell accurately when it is going to explode as a supernova. But only few people, I mean, maybe a little bit more than few, but, they detected or they observed, they witnessed, with the correct terms, a supernova. So we said first Chinese, it started with Chinese people. And then it is estimated that supernovas happen only in about 100 years.
So this is something that always bothered me about supernova a little bit. Maybe you can expand on it a little bit. Nova means new, but you're not really getting. I mean, a star is dying. That feels like a weird thing to me that somebody decided to name a new star, name a dying star a new star. I don't know.
Now, the reason is before we knew what was going on, the supernova explosions happen at the last stages of, or it's the beginning of the last stages. Okay, but what they observe in the sky is like a light coming up, getting brighter and brighter and brighter. And this is called new star because it looks like a new star in the sky.
That makes sense.
But it is actually the beginning of the death of that particular star. But our understanding came later. That's why we are doing science, right?
Yeah, I guess.
To understand what's going on. But we may name it differently. There's a lot of things named differently that after our understanding, it is changed. And let me show you an example. Let me show you the Ring Nebula.
All right, here we go.
Ring Nebula is a planetary nebula. It's called Planetary Nebula. It's another wrong name.
Oops.
Because the reason is, you can also find it under the night sky tonight. It's in the Summer Triangle. There's a constellation called Lyra. Lyra has a very bright, popular star in it. It's called Vega. Vega is sun-like star. It is the twin brother or sister of our sun. With a lot of properties, it is very similar to the sun. So Vega is, I see constellation Cygnus over here, the stars, the Nep, so Vega should be close. Yes, here is the Vega. Vega is, if you find this parallel shaped constellation, you can easily identify the star Vega. And in this constellation, when astronomers, or if you go to star party someday, ask them to show you the Ring Nebula or to show you a planetary nebula. They will point the telescopes over here and they will show you this amazing object. So this amazing object is actually another dead star, but this star was not 3 times more massive than the sun. This star was less massive than the sun. Maybe it was similar to the sun. Okay, when they first look at with a telescope, they called it Planetary Nebula because the imagination was, or the astronomer who was observing was thinking that he found a star, but that star showed a resolving planet around it. So he imagined it as like a Jupiter-sized planet, completely resolving and leaving the gassy trail behind it when it is orbiting.
And we do know that it actually looks really similar when we found a true planetary, air quote, nebula. Here's the image of the...
Exactly.
This is what it looks like.
This is Planetary Nebula, can be called Planetary Nebula, rightfully. But this is not actually a planetary nebula. But it is called Planetary Nebula because it was named first, and then our understanding came what it is later. So what it turns out that, yeah, it's a star dying. It's a small star. The star is becoming white dwarf at the center. But there's a speculation, though, to what I'm going to say. The star at the last stages started resolving and started ejecting all the gas outside of the star, and this star formed a shell, gassy shell around the star. But some actually speculated this and said well, that material was not ejected from the star. It was around the star always, and after the white dwarf is dying, then we just happen to see that around. So we don't know which one is the correct one. So again, if the star dies this way, it turns into a white dwarf, which is a star does not have the capacity to produce and heat and light. It is just cooling off. Very interesting.
Definitely interesting.
So this is how we get information from stars. This is how we get information from the universe. And there is a lot more we can explore, which requires probably 10 different episodes.
I know we don't have time. Well, maybe we do have time in this episode. It's really up to you. We could probably turn this into a new episode. But we talked about stars our age. Some question that Brexton asked that I thought was kind of interesting, and I'll read it. And maybe he meant to use a different word, maybe he didn't. I don't know. But so the question was: so if a planet explodes, does its particles turn into a star eventually? So he's asking, when there's a bunch of debris, does it eventually turn into a star? I don't know if you want to make this its own episode, but you could answer the question. It's up to you.
So when a star or planet explodes?
He said planet, but I mean, you could maybe address both. So your choice.
Well, planets likely do not explode unless they crash into something. Two planet crashes likely also happen. And what is going to happen after first? Yeah, the planet partially or completely may turn into a debris, but that debris is going to be hot because of all the energy carried by the collision. And that hot particles are pretty much like a molten lava. They will also attract each other gravitationally and combine and form another planet. And this is what we think actually happened to the moon. We are understanding that the Earth collided with about Mars-sized object, but it was not a direct collision. It was a side-swipe collision, and it took chunk of debris from the crust of Earth, and that debris surrounded around Earth and over time combined to form the moon. If stars explode, that's a different story. When stars explode, most of the gas and dust is spreaded across the universe. And guess what type of gas and dust it is?
What?
What are the stars made of?
They are made of hydrogen and a little bit of helium.
Yeah. So, but what spreads around the universe is not hydrogen or helium, because they are, remember, they are consumed.
Ah, you're right.
They are the source or fuel of the nuclear reactions, nuclear reactor at the center of the stars, and they were turned into different elements. Like anything you can name on: aluminum, iron, silicon, carbon, you name it, magnesium, a lot of things. And those materials, sink at the core of the star, and with the explosions, most of these materials are spreaded into the surrounding universe. And can you show me the Orion Nebula?
Definitely. Let's switch back to the other side of the sky real quick, and
let's go back to Orion again. It is interesting. This part of the sky is a great astrophysics laboratory. At the heart of Orion, there is another nebula, and which is right here. You can even see it by yourself. You don't need to use any telescope. The Orion Nebula is actually a star birth region. Orion Nebula is big amount of gas and dust, and it makes new stars. Astronomers call this object stellar nursery. So how stars form in these clouds are very, very different story. But from the exploded stars, when the materials or the elements we know of spread around the universe, they sometimes travel through these gas clouds. And they are contributing, involving, mixing in with existing hydrogen gas here. Pretty much adding spices into pure hydrogen. And when new stars form, they contain mostly hydrogen, which is needed fuel for the rest of the star life, but they also contain traces of different elements. How do you think the helium got into the sun in the first place? We know there's helium in the sun. Yeah, it is produced in the core by the nuclear reactions, but on the outer layers there's also helium. Plus, when the stars are forming, the lighter materials sink at the center and the heavier materials surround around. So those materials are forming planets, and that's how we got most of the heavy elements on Earth, like magnesium. Sun haven't made magnesium yet. Sun haven't carbon yet. But we have these elements on Earth because it made in different stars, travel across the universe. They got into, mixed into the solar nebula. And when the solar system was formed from the solar nebula, that materials existed in the solar nebula already. That formed Earth, and we found them. So everything, when you look around, look at the different elements you see, even if you are, sitting on a chair, all the materials, including aluminum and iron and anything that was made to that was included to make that chair was actually made in stars. If you like jewelry, the gold we found on Earth, and all other items, all other jewelry stones, including diamonds. Only stars make diamonds. So they were made in stars.
Pretty spectacular, for sure.
So, do we have any other questions, Jim?
I think that's really it.
We would like to thank you to our viewers, by the way, coming up with really, really great questions. We truly appreciate it.
Lamia asked about sun-sized stars exploding.
It has to be at least 3 times massive than the sun. The sun-like star is going to turn into a white dwarf, potentially something like ring nebula, or maybe just a white dwarf without surrounding gas.
Definitely interesting.
On another episode, we should cover the life cycles of stars, how they form in the first place and how they die.
On the way out, since you said it, we get to bring up this little quote from
exactly. The cosmos is also with us. We are made of star stuff for that reason. We are made, he says, because our building blocks are carbon, and carbon is also the produce of stars. So he's right. We are star stuff.
Pretty wild, pretty beautiful. Definitely very deep. A few other things that people said. Brexton said he owns lots of stars. You're very welcome, Lamia, and thank you guys for all the support. We're getting tons of. I don't know if you can read it up there, Levent. You can kind of sort of read it over there on your monitor, but got a lot of feedback. Seems like it was a successful episode.
That was great. So we are always here to explain the things that is going around us. And if you have questions, please put it in the chat, put it in the comments.
Yeah, topics for us to cover next time. We won't be here next Friday, I don't think.
Yeah, we won't be here next Friday.
The Friday after that, we will.
But
right?
we'll be here next week, Wednesday.
Yes.
On Facebook. Well, see you on next Wednesday.
Yeah. See you, everybody. Bye bye.
Bye bye.